Hi, this is Andrea Hendricks, and I want to talk to you about solving quadratic equations by the square root property. We're going to begin a series of discussing ways on how you can use different methods to solve quadratic equations. So let me first start by reviewing some of the things that you already know, and that is how to solve a quadratic equation by factoring. And I've started here with some problems that are of a certain type because it's going to lead into the method that we're going to talk about. But let's talk about if I had x squared equals 25 and I wanted to solve by factoring. Do you remember that to solve by factoring you have to set the equation equal to 0, which means you would have to subtract the 25 from both sides. And then you would have to factor this or binomial, whatever it is, this polynomial, x squared minus 25, which happens to be the difference of squares. So it factors as x minus 5 times x plus 5 is equal to 0. And then we would set each factor equal to 0 and find that our solutions are 5 or negative 5. And you remember that the degree of the equation indicates how many solutions you should have. So a degree 2 equation means that we should have 2 solutions. Looking at x squared equals 36, you would have x squared minus 36 is equal to 0. This too is a difference of two squares. We'd factor as x minus 6 times x plus 6. And then setting those factors to 0, we would have either x is positive 6 or x is negative 6. So again, our solution set is negative 6 and 6. X squared equals 4. Similar problem, x squared minus 4 is equal to 0. So that would be x plus 2 times x minus 2 equals 0. Setting those factors to 0, we get x plus 2 equals 0, or x minus 2 is equal to 0. So our solutions are negative 2 or 2. Now, these are of a special type, and do you notice how the solutions relate to the number that is set equal to x squared? If x squared equals 25, our solutions are 5 and negative 5. If x squared is equal to 36, our solutions are negative 6 and 6. If x squared is equal to 4, our solutions are negative 2 and 2. Those solutions are the square roots of the number that's on the right. So that leads to a property that we can actually use for special types of equations. If k is a real number, and if x squared is equal to k, then x is going to be equal to plus or minus the square root of k. Or you can write them separately, x is equal to square root of k, or x is equal to the negative square root of k. So like the equation that we had just before, x squared is equal to 25, to apply this property, we would say that x is equal to plus or minus the square root of 25, which gives us plus or minus 5. So what we're doing is we are undoing the square, and to undo the square we have to apply the square root. But when we do that, we get a positive and a negative value. I tell you the most common mistake is to forget the plus or minus. So you have to remind yourself that if there are a degree of 2, there's going to be 2 solutions to the equation. So let's apply the square root property. Again, I'll write it here. If x squared is equal to k, then x is equal to plus or minus the square root of k. So we have to get our initial equation in this form where x squared is on one side and the number is on the other. So we may have to do some work for that. Like x squared minus 9 is equal to 0, to use the square root property, we would add 9 to get x squared is equal to 9. Now that it's in this form, we can apply the square root to get x squared is equal to 9, which means that x is equal to plus or minus the square root of 9, or plus or minus 3. Now, in my math lab, you're going to have to enter those as 2 separate solutions, negative 3 and 3. It doesn't have the plus or minus. If x squared is equal to 7, it's already in the form we need. So that means that x is equal to plus or minus the square root of 7, but that can't be simplified at all. So our solutions are the square root of 7 and then negative square root of 7. X squared plus 4 is equal to 0. We have to do some work. We have to subtract 4 from both sides. So that gives us x squared is equal to negative 4. Applying the square root property gives us x is equal to plus or minus the square root of negative 4. But we just learned this. The square root of negative 4 is 2i. So our solutions there are negative 2i and 2i. Okay. So there's really three types of solutions you can have. Rational solutions, that is numbers that could be written in the form of a fraction where the numerator and denominator are integers. Irrational, where the decimal form never repeats or doesn't have a pattern or ends. And complex solutions. So those are the three cases you can have. So this is a type of equation, or property rather, that can help us solve lots of equations that maybe we couldn't solve by factoring. Looking at some more examples, again the idea is to get the x squared to one side. So we'd have to first add 24 to get 3y squared is equal to 24, and then divide through by 3. So y squared is equal to 8. And now applying the property tells us that y is equal to plus or minus the square root of 8. It's not going to leave it in that form because that can be simplified. Remember that 8 is really 4 times 2, so that can be written as plus or minus 2 on the square root of 2. Now x minus 1 squared is equal to 16. It looks different in the sense that we have a binomial that's representing our x, but it's still of the form where the something squared is on a side by itself. So we can still apply the square root property. And whenever we apply the square root property, we remove the square on the left. So that leaves x minus 1 is equal to plus or minus the square root of 16. So x minus 1 is equal to plus or minus 4. We can solve for x by adding 1 to both sides. So x is equal to 1 plus or minus 4. So that really means that we get 1 plus 4, or x is equal to 1 minus 4. So we have two solutions, 5 and negative 3. Okay. Let me go back and write these in the solution set form. Okay, if x plus 2 squared is equal to 5, same thing. To eliminate the square, we apply the square root, so we get x plus 2 is equal to plus or minus the square root of 5. So now we have to subtract 2 to get x is equal to negative 2 plus or minus the square root of 5. So one solution is negative 2 plus the square root of 5. The other solution is negative 2 minus the square root of 5. Okay? And those are irrational. Unless your problem says to approximate the solutions, you can leave it in this exact form. Otherwise, you would have to use your calculator and find out what the decimal form of that value is. Okay. A couple of applications. The area of a circle is given by A is equal to pi r squared. If a circle has area of 81 pi square inches, what is its radius? So here we're going to replace the area with the value 81 pi. It's equal to pi r squared. We're in the section to use the square root property, so we want to isolate the square term. So we divide by pi. So we get r squared is equal to 81. So if r squared is equal to 81, r is going to be plus or minus the square root of 81, which would be plus or minus 9. So it's saying that the radius is either 9 or negative 9, but obviously negative 9 doesn't make sense in this context, so our radius is going to be 9 inches. Okay. One last problem. The amount A that P dollars invested at an annual interest rate R will grow to in 2 years is given by this formula. A is equal to P times 1 plus R squared. At what interest rate will $100 grow to 110.25 in 2 years? So plugging in everything first understand what our A and P are. We invested $100, so that's P, and this is what it's grown to, so that is our A. So plugging in, we get 110.25 is equal to 100 times 1 plus R squared. So here again, we've got to isolate the squared binomial. To do that, we've got to get rid of 100. Here again, I have some common mistakes. We don't subtract 100, that's connected by multiplication. We have to divide both sides by 100. So when we divide 110.25 by 100, we get 1.1025 is equal to 1 plus R squared. So let me write that over here again. So we can apply the square root property to get 1 plus R is equal to plus or minus the square root of 1.1025. And I'm hoping that that number has a pretty nice square root. And it does. The square root of that number is 1.05. So to solve for R, we have to subtract 1 from both sides. We always put that in front of the plus or minus. So this tells us that R is equal to negative 1 plus 1.05, or R is equal to negative 1 minus 1.05, which gives us R is equal to 0.05 or negative 2.05. But we can't have a negative interest rate. So R is equal to 0.05 is our answer, and 0.05 is the same thing as 5% interest. Okay, so that concludes this lesson on using the square root property to solve quadratic equations. Please contact me if you have any questions. Thank you.